Very good morning to one and all. Today I'm going to discuss about construction and working of induction type single phase energy meter. The meter which is used for measuring energies utilized by electric load is known as an energy meter. On the screen we are showing single phase induction type energy meter. The energy meter is the total power consumed and utilized by the load at a particular interval of time. It is used in domestic and industrial AC circuit for measurement of power consumption. The meter is very less expensive and accurate. Coming to construction, the diagram shows single phase induction type energy meter consists of driving system, moving system, braking system, and resistance system. The entire parts of the energy meter is divided into four systems: driving system, moving system, braking system, and resistance system. Coming to driving system, the driving system consists of temporary magnet and the electromagnet made up of silicon steel laminations. And the upper one is called as electromagnet, shunt magnet. The upper electromagnet is represented as a shunt magnet, and the lower magnet can be represented as a braking magnet. And the moving system is made up of aluminum disc mounted on the shaft of the alloy. The disc will be placed in the area of the two electromagnets. Braking system. The permanent magnet the permanent magnet is used for reducing the rotation of the aluminum disc. Resistance system. The main function of resistance or counting mechanism is to record the number of rotations of the aluminum disc. The rotation is directly proportional to energy consumed by the load in kilowatt hour. That's why you are represented the units for energy meter is kilowatt hour. Coming to working of the energy meter, the energy meter as the aluminum disc whose rotation determines the power consumption of the load. The disc is placed between air gap of the series and shunt magnets. The shunt magnet has pressure coil and series magnet has current coil. The pressure coil creates the magnetic field because of supply voltage, but the current coil produces flux because of the current. Then the interaction of the eddy current and magnetic field caused by torque which exerts a force on the disc. Disc starts rotating. The force on the disc is proportional to current and voltage of the coil. The permanent magnet controls their rotation and the permanent magnet opposes the movement of the disc and equalizes it on the power consumption. Finally, based upon the magnetic field interaction of the shunt magnet and the series magnet, the force will be applied on the disc, then the disc will be rotated towards the deflecting force. While you are applying any braking on the disc, then you are using the braking magnet. So this is about overview of the single phase energy meter. And some of the errors also possible in the energy meter. That is creeping error. Creeping error, what is the meaning of creeping error? Creeping error energy meter is the phenomenon in which the aluminum disc rotates continuously when only the voltage is supplied to the pressure coil and no current flows through the current coil. In other words, the creeping is kind of error in which the energy meter consumes a very small amount of energy even when no load is attached to the meter. Without applying any loads, the energy meter consumes some amount of energy in the component of the energy meter that is represented as a creeping error. So, how to reduce creeping error? So, the creeping error will be reduced by we have to applying some whole mechanism on the aluminum disc. Then the aluminum disc stops rotating even when small edge of the disc comes under pole of the magnet. The holes will limit the revolution of the disk. And so the second type of errors possible in energy meter is speed error. This type of speed error is due to the incorrect position of the brake magnet. The braking torque is not correctly developed. This can be tested when meter runs it on the full load current alternatively. On the loads of the unit power factor, and the low lagging power factor. And the third type of error possible in energy meter is meter phase error. Meter phase error is nothing but an error due to incorrect adjustment of the position of the shading band results in an incorrect phase displacement between magnetic flux and supply voltage. And the fourth type of error is friction error. An additional amount of driving torque is required to compensate this error. And the last one is temperature error. Temperature error. The energy meter is almost inherently free from errors due to temperature variation. Temperature affects both the driving and braking torques equally. And this is a very, very important concept, not only for exam point of view. This is very important concept for uh, daily use of energy meters for measurement of how much amount of energy consumed by a particular system or home or any particular load. This is about simulated energy, induction type energy meter.